Although earthquakes are by far the most common cause of tsunamis, there is another source for these deadly waves: landslides. And these tsunamis have the potential to be so big that they have been called mega tsunamis. Scientists had long suspected that waves could be generated in this way, but conclusive photographic proof wasn't available until 1958. A landslide into Latoya Bay in Alaska triggered a wave that reached heights of several thousand feet. This footage, shot just after the tsunami struck, shows the wave's enormous power. The trees here once stretched all the way down to the shores of the bay, but were ripped off the slopes by a wall of water, leaving nothing but bare, exposed rock. The tsunami was generated when a relatively small earthquake triggered a single enormous landslide of rocks and debris into the bay. The resulting wave was higher than the Empire State Building and stunned scientists around the world. Tsunamis on this scale are incredibly rare. But another mega tsunami, triggered by a rockfall 10,000 times bigger than Latoya Bay, could be on its way from a small island across the Atlantic Ocean. The Canary Islands off the coast of Africa are formed from a series of volcanoes. The youngest is the island of La Palma. It is formed from two volcanic ridges. The first is the extinct Cumbri Vieja to the north of the island. The younger, active Cumbri Vieja lies to the south. It erupted as recently as 1971. Geologist Dr. Simon Day's research was crucial in developing the La Palma megatsunami theory. It began with an unusual rift that had opened up during a major volcanic eruption in 1949.
We're standing here in the fault, and it runs way down to the south along the crest of the volcano for 2.5 miles. So it's one continuous long structure.
Day believes this fault is evidence of a geological time bomb, the beginning of a giant landslide.
What we see here to my right are layers of volcanic rocks, volcanic blocks here, and layers of volcanic ash. And on the west of the fault, we see the same layers of blocks and ash, and those, before the fault moved, were joined up, and then when the fault moved, they were separated, and the rocks to my left moved down and to the west. What we think will happen in some future eruption is that this fault will have gotten bigger, and the whole of this western side will slide away in a giant landslide into the ocean to create the tsunami.
This landslide would send the entire southwest section of La Palma, 1/6 of the island's total mass, crashing into the Atlantic Ocean in a single giant landslide.
What we envisage is the whole of this coastline and the slope extending up all the way to the crest of the volcano that is now in the clouds. All of that mass of rock would slide away in a single massive landslide into the ocean and pushing the water up in front of it to create the tsunami wave.
Initially, this wave would be over 30 times bigger than the 2004 Indian Ocean tsunami, more than 3,000 feet high. The 1980 eruption of Mount St. Helens was proof that a volcano could collapse in this terrifying fashion. This was impressive, but the collapse of the Cumbri Vieja would be 200 times the volume of this. 1,200 billion tons of rock would hurtle towards the ocean at top speed. The resulting wave would head straight out into the Atlantic.
That wave, of course, would then spread out and separate out into smaller waves. But even so, after crossing the Atlantic and piling up again on, for example, the eastern seaboard of the United States or in the Caribbean or in northern Brazil, the waves there, we predict, would still be between 30 and 100 feet high. So that's as large as, if not larger, than the tsunami that struck Sumatra in 2004.
Boston. New York. And even Miami could all be under threat from the giant waves.